Hello students. So the next topic that we are starting today is Newton's laws of motion. The fourth topic in new 11th standard state board textbook, laws of motion, and we will start with the question straight away. So the first question you will find in the exercise is a truck of mass 5 ton is traveling on the road with 36 kilometers per hour, stops on traveling 1 kilometers after the engine failed. What fraction of its weight is frictional force exerted by the road? Now see, normally you will come across this type of question. What fraction of one quantity is the second quantity? See, whenever you will see this thing, what fraction of quantity X is quantity Y? What fraction of quantity X is quantity Y? Means in the question it is asked, what is the value of Y by X? Sometimes it could be asked in this way, what percentage of X is Y? What percentage of X is Y? ऐसे question होगा तो it is Y by X into 100. What percentage is asked, then you have to multiply by 100. If what fraction is asked, only it is Y by X. So in this question, what fraction of its weight, means weight, what fraction is frictional force? So in this question, what is asked? To find, what is asked is to find frictional force upon weight. This is what is asked in this question. What is the value of frictional force by weight? So now we will see how to calculate it. Frictional force by weight. Everyone knows that weight is mg. Weight is mg. Weight of car is mg. And what is frictional force now? Since we have not started with friction yet, I won't use the formula of frictional force as coefficient of friction times normal reaction. What I will do is I'll use the data that is given over here. It is given that the truck of mass 5 ton is traveling on the road at the speed of 36 kilometers per hour. Now clearly it is not given in SI units. 36 kilometers per hour. You know that how to convert into meters per second. Multiply it with 5 by 18. This will become meters per second. 18 2s are 36, so it is 10 meters per second. So truck is traveling at 10 meters per second and it stops suddenly after traveling 1 kilometer because of engine fail. Now suppose truck engine fails. Which force will stop the truck? The answer is frictional force. Frictional force will resist the motion and finally the truck will stop. So in this particular question, to find how much frictional force is acting, you can take two different approaches. One is using kinematical equations and the other approach is using work energy theorem. One method is work energy theorem and other is using kinematical equations. Kinematical equations will give you retardation and from retardation you can find the force. But this one is easier, work energy theorem, and it states that the change in kinetic energy of that truck is equal to the work done. When the truck was traveling at the speed of 10 meters per second, it finally goes and stops. So इसमें जो उसका kinetic energy change हुआ है, the change in kinetic energy is because of what? It is because of friction against the direction of the car. So, or the truck. The truck का initial kinetic energy is half mv square, right? And finally when it stops, its final kinetic energy is 0. So what is change in kinetic energy? The change in kinetic energy can be given as, the change in kinetic energy will be half mv square minus 0, that is half mv square. This is change in kinetic energy. And this much work is to be done by the frictional force, which is constant frictional force. And how to calculate work done by constant force? It is frictional force F into how much distance it has covered before stopping, which is 1 kilometer. So F into S. So equating these two things, I will get the value of frictional force. कितना मिलेगा frictional force का value? So the fraction frictional force upon weight will be equal to what? F. What is F का value? Half mv square by S. S will go down. This is the value of F divided by mg. So what will cancel in this? M will cancel and you will get that fraction F by W What is the value of this fraction? F by W, it is V square. See, V square by 2G and S. 2G and S. And now you have to simply put the data. What is the fraction? Tell me, what is velocity? Velocity is 10. So if I put the value, velocity as 10, 10 square is 100. SI units में सब put करना है. 2G acceleration due to gravity, we will take it 10. And displacement is 1 kilometers. 1 kilometers is 1000 meters. 1 kilometer is 1000 meter. So if I solve this, 2 zeros will cancel and the answer that we get is 1 upon 200. This is the fraction of frictional force to weight. The fraction of weight, that is frictional force, is 1 by 200. But in this question, the second part is, if we assume everything, the same story repeats, but if the mass instead of 5, if it is 1 ton, now what will be the fraction? But if you observe it carefully, कि ये जो fraction है, frictional force upon weight का, the fraction, which we have derived its answer as V square by 2gs, there is no mass term present in this. And as there is no mass term present, ये mass पे depend नहीं करेगा. 5 Newton, 5 ton हो, 1 ton हो, 10 ton हो, 20 ton हो, it is independent of mass. We have derived the formula. This is the formula that we have derived. And it is clearly independent of mass. So answer will remain 1 by 200 in both cases. Both cases means for 5 ton as well as for 1 ton. For both the cases, the fraction will remain 1 by 200. So the next question is question number 2. A lighter object A and heavier object B are initially at rest. Both are imparted same linear momentum, which will start with a greater kinetic energy. Now in this case, both objects A and B, this is object A and this is object B. Clearly given, B is heavier, so mass of B is greater than mass of A. But both are given same linear momentum, and linear momentum is basically the product of mass times velocity. So दोनों का linear momentum is same, which will have more kinetic energy. So if I use the formula of kinetic energy to see किसका kinetic energy will be more, I can write the formula as half mv square. Now we know that mass of B is greater, but we don't know about velocity. We know that the product of mass into velocity is same. So what I will do is, to compare kinetic energy, somehow I will write the equation of kinetic energy in terms of linear momentum, because I am sure the linear momentum is constant. So somehow I need to make linear momentum over here. So I can do it by two ways. I can multiply by mass, divide by mass. It will become half m square v square by m, which is half p square by m. This is one way. And the other way is, instead of multiplying and dividing by mass, if one velocity is given to this kinetic energy, the other way can be written as half mv times v, which is half mv square, and which is also written as half pv. This is momentum, this is velocity. Now since we know that both the particles are given same linear momentum, दोनों के लिए p is constant. P is constant. So kinetic energy will be more for a particle having lesser mass or greater velocity. But in this question, mass are given, not the velocities. So in this question, clearly it is given that A ka mass is less, the mass of A is less, B object is heavier, mass of B is large. So from this expression, as kinetic energy is inversely proportional to mass for constant linear momentum. For constant linear momentum, the proportion is inverse. And as mass of A is less than mass of B, it is given in the first statement straight away. Therefore, kinetic energy of A will be greater than kinetic energy of B. This is the answer for question number 2. Kinetic energy of object A will be greater than kinetic energy of object B. The next question is question number 3. As I was standing on a weighing machine inside a lift, it recorded 50 kg weight. Suddenly, a few seconds, it recorded 45 kg. What must have happened during that time? So in lift, first you must know what happens in lift when you are standing on a weighing machine. Suppose this is lift. and in this lift, if you are standing right on a weighing machine, this is weighing machine and a person is standing on weighing machine, the true weight of the person is shown for two cases. First, if the lift is at rest, the weight of the person mg will be shown by the weighing machine, or if the lift is moving up or down with constant velocity. If the lift is moving up or moving down, that is not important. Lift is moving in any direction with constant velocity. If the lift is moving in any direction with constant velocity, the reading will remain same. The problem or the change in the reading only occurs when the lift starts accelerating or retarding. So remember, the direction of velocity means whether the lift is moving up or lift is going down is not important. The direction of acceleration is important to calculate the change. So already I have stated that if the lift is at rest or if it is moving with constant velocity, you will get your true weight. You will get the true weight, that is mg, true weight. But if the lift is accelerated, you will get some apparent weight. You will get some apparent weight which will be mg plus or minus a, depending where the lift is accelerated, not where the lift is moving. Okay, so it may happen the lift is moving up, but it is accelerated down. Means lift is moving up and it is slowing down. As it slows down, acceleration is downward. It may happen that the lift is moving up as well as it is accelerated up. This may happen. Next case is, it may happen that the lift is actually moving down, but it is still accelerated upward. Means it is retarding. It is going down and the speed is decreasing. And it may happen that the lift is going down as well as it is accelerated, as well as it is accelerated downwards. So remember, this formula is only valid when accelerations are present. And in this formula, we are not interested where the lift is moving, whether it is moving up or it is moving down. We are interested only in the direction of acceleration, right? So whenever acceleration is downward in lift में acceleration अगर downward होगा, the pseudo acceleration or the pseudo force acting on the particles or the objects inside will be in upward direction, which will oppose the acceleration due to gravity. So whenever the lift is accelerated down, I'm not saying that it is moving down. When the lift is accelerated down, it may move up. When it is accelerating down, downward acceleration, in that case, we go with the formula mg minus a. Because clearly, the pseudo acceleration is opposing gravitational acceleration. So first case. And second case, when the lift is accelerated upwards, the pseudo acceleration will be downward, helping gravitational acceleration. Gravitational acceleration is always downward. Gravitational acceleration को help करेगा ये. So in that case, the apparent weight will be mg plus a. Means it will be greater than true, less than true. So in this example, when I was standing on a weighing machine inside lift, the weight that I recorded was 50. Suddenly something happens and the weight decreases. The weight decreases means the acceleration was downward. It doesn't mean the lift starts moving downward. No, acceleration was downward. So either initially the lift was moving with a constant velocity upward, I recorded my true weight 50, and suddenly it starts stopping, it starts retarding. In that case, acceleration was downward. So the weight reduced. So in this particular example, what is the true weight? The true weight is 50. And then what is the apparent weight? It is 45. And whether I should use g plus a or minus a? I should use minus because the weight has reduced. So minus. And if I take the ratio, if I solve it, mm will cancel. This will become 9za and 10za. So 10 by 9 is equal to g upon G minus A, on cross multiplying this, what you will get? 10G minus 10A equals to 9G. And then solving this, 10A will go to the right side. 10A is G because 10G minus 9G is G, and therefore acceleration of the lift is G by 10. So the final answer for this question is yes, the change in the weight is because of lift is accelerated downward with the acceleration of G by 10, one tenth of gravity. In this question, the answer should not be in this way that the lift is moving down with acceleration. No, lift could be moving in any direction, upward or downward, we are not sure. But lift was accelerated downward, and the answer is the lift is accelerated downward with G by 10, the value of G by 10. Okay, so the next question is question number 4. The figure shown below, it shows the block of 35 kg resting on a table. It provides resistive force 10% of its weight, which is adjusting. Means if this is 35 kg block, then its weight is how much? 350 Newton. So uska 10%, iska 10% is how much? 10% of this is 35 Newton. So this block will resist up to 35 Newton. Means is block pe if I apply इस direction में 10 Newton, whether the block will slide? No, it won't slide. 15 Newton को slide नहीं होगा, 20 को it won't slide, 25 को it won't slide, up to 35 it is not going to slide. Similarly, if I apply 35 Newton over here, till 35 Newton if I apply, the block will not slide. The block will start sliding after 35, after crossing 35. That is the meaning of adjusting force. Okay, the weights of 1 kg each can be added to this pan. So in this figure 35 kg weight, इधर से 2 kg का pan, इधर से 20 kg का weight है. And in this pan you can add 1 kg के small weights. So these are 1 kg के weights. Sir, 1 kg के weight. I can lift and put it in this pan. So minimum how many of such weights I can put, and maximum how many weights I can put, so that the pan does not slide. The block does not slide. Okay, so the block should not slide. For that, how many weights minimum and how many weights maximum I can put in this pan? Is pan mein how many weights I can put? Tell me right now at this particular moment for this figure, can this 35 kg block, whether it is moving or it should be at rest? At this particular case, if you observe it carefully, यहाँ से कितना फोर्स है नीचे? 200 न्यूटन. 20 kg मतलब 200 न्यूटन. यहाँ से कितना है? 20 न्यूटन. सो क्लियरली ये जो फोर्स है 200 न्यूटन, ये जो फोर्स है 20 न्यूटन, ये बहुत ज्यादा है. दिस इज वेरी लार्ज. 180 न्यूटन. ये सेल्फ एडजस्टिंग 35 के ऊपर का है. 180. सो द ब्लॉक इज राइट नाउ स्लाइडिंग. क्वेश्चन इज द ब्लॉक शुड नॉट स्लाइड. हाउ मेनी मिनिमम एंड मैक्सिमम वेट्स यू कैन पुट? सो स्ट्रेट अवे एकदम इजी वे है. व्हाट आई विल डू इज फर्स्ट आई विल मेक बोथ द वेट्स इक्वल. सो आई विल पुट, कितने इसमें डालने हैं वेट्स? इसमें 2 kg ऑलरेडी है. इफ आई पुट 18 सच वेट्स, 1 kg का 18, this will become 20. This is 20. So if I start with 18 weights, okay, 18 weights, 18. Okay, I'll write the number only. Tell me, if I put 18 weights, what will be the net force on the block? Net force on the block will be 0. Because 18 put किया तो 18 plus 2 is 20. 200 Newton, 200 Newton, 200 Newton, 200 Newton. Net force 0 हो गया. So the block will not move. Now I will go for maximum पहले. Maximum how much I can put? If I put 19 weights, ये कितना हो जाएगा? 21 kgs हो जाएगा. 21 kg मतलब 210. This will become 210. This will become 200. So still net force कितने का है? 10 Newton का है. 10 न्यूटन का नेट फोर्स है. बट ये सेल्फ एडजस्टिंग जो है ना, उसका मैक्सिमम वैल्यू है 10%. 10% ऑफ 350. ये 350 है इसका वेट. 35 न्यूटन का सेल्फ एडजस्टिंग फोर्स है. 35 न्यूटन तक चलेगा. 10 न्यूटन इट इज इनसाइड 35, सो द ब्लॉक इज नॉट गोइंग टू मूव. और एक ऐड किया, 20 वेट्स ऐड किए, तो 20 वेट्स ऐड किए यहाँ पे, तो ये 22 kg का पैन, 20 वेट्स है, 22 kg है. 22 kg is 220 न्यूटन. ये 200 है. सो कितना नेट फोर्स है? 20, still the block will not slide. 21 को slide होगा क्या? 21 को it will become 30 Newton का net force, still it won't slide because 30 is less than 35. लेकिन अगर if you cross this 21 and go for 22, it will become net force of 40 Newton and the block is going to slide. So block will slide after 21. So maximum 21 you can put. Now we will go for the minimum. Minimum how many weights I can put? 18 को तो 0 force था. If I remove one, 17. If I make it 17 weights, so 17 plus 2, 19 kg. 19 kg मतलब यहाँ से 190 Newton, यहाँ से 200 Newton. So net force इधर है. So self adjusting force यहाँ पे लगेगा 10 Newton का. So it will balance out. No problem. 17 पे 10 Newton. Net force 10 Newton. Self adjusting can balance it. 16 किया तो if I make it 16 weights, 16, this will become 18 kg, 180 Newton. 180 Newton मतलब net force of 20 Newton over here, which will get balanced by 20 of self adjusting. So 16 भी चलेगा 20 Newton. Similarly 15 will also work. Net force 15 will also work because 15 weights अगर put किए तो 17 kg होता है, वो 17 kg is 170 Newton. 170 Newton में तो 200 इधर 170 इधर, so 30 self adjusting, which is fine because maximum limit is 35. But if I remove one more weight now, अगर और एक weight निकाला, if I make 14 weights only, यहाँ से और एक weight निकाला, this will become 16, 160 and 160 में now net force will become 40 over here, but self adjusting 35 कर पाएगा and the block will slide. Okay, so this will become 40 net force इधर and therefore the block will slide. In these cases, in all these cases, net force acting on the block was less than 35. So whenever force was less than 35, that is the maximum limit, the self-adjusting force was cancelling that force and net force used to be 0. So in these cases, the block will not slide because net force acting is less than the self-adjusting, means self-adjusting can balance out that force and make the net force 0. So this is the answer. Minimum 15 to maximum 21 weights I can put in that pan. Okay, so the next question is question number 5, and in the fifth question it is asked that power delivered by the force is proportional to time. Which power of time? T raised to 1, T raised to 2, root T. Options are given. So basically this question is questions based on dimensional analysis. Question based on dimensional analysis, and question is what is the relation between power, force, mass and time. And how do we solve these type of questions? We start with in this way: power proportional to F raised to x, m raised to y and t raised to z, and we simply put the dimensions and get the values of x, y and z. So let us solve it. P equals to some constant k, f raised to x, m raised to y, t raised to z. Power, dimension of power will be constant, has no dimension. Force ka dimension raised to x, mass dimension raised to y and time dimension raised to z. What is dimension of power? Power is work upon time, so L2 m1 t minus 3. What is dimension of force? L1 m1 t minus 2 raised to x. What is dimension of mass? Mass itself is fundamental quantity, m1 raised to y, and time is also fundamental quantity, so t1 raised to z. And if you solve it now, L raised to, L is in the first term, no L in the second and third, so L raised to x, m raised to x and y, so x plus y, and t raised to minus 2x plus z is equal to L2 m1 t minus 3. Comparing the powers, x equal to 2, the first value we get, x equal to 2. From this what you get is x plus y is 1, but x is 2. So y will be 1 minus 2, that is minus 1. And from the third, minus 2x plus z equals to, t ka power is minus 3 over here, x is 2. So if I put 2 over here, minus 2, 2 is a minus 4, minus 4 will go to the right side, z will be minus 3 plus 4, that is 1. So z is equal to 1. So from this expression we get power is proportional to f raised to 2, m raised to minus 1, t raised to 1. So the formula becomes some constant f square t by m, and clearly power is proportional to time raised to 1. So the answer is power proportional to time raised to 1. Okay, so the next question is question number 6. 40,000 liters of oil of density 0.9 gram per cc. Now clearly this is not given in SI units as well as liters is not in SI unit. Is pumped from oil tanker ship into a tank 10 meters higher level than the ship. So from a tanker ship, the oil is pumped up by 10 meters to the higher level in half an hour. Then what should be the power of the pump? Now we know that power is rate of work done per unit time. Now in this case, the work is done in form of potential energy to increase the level of the oil from the level of tanker ship to the level of the tank, which is 10 meters above. How much work is required? Work required is mgh. The work required is mgh, that is increasing the potential energy. Upon the time taken, which is given in the question, it is half an hour, that is 30 minutes. Now clearly mass is not given directly, it is given in terms of volume of the oil and density of the oil. Using volume and density, we can find the mass. I will find the mass over here separately. Mass upon volume is density. So mass can be calculated as density into volume. But the problem is with the units. The units are not in SI. So density is 0.9 gram per cc into the volume is 40,000 liters. 40,000 liters. So liters is 1000 cc. 1 liter is 1000 cc. So this cc centimeter cube will cancel in the multiplication, and 0.9 gram into 40,000 into 1000. Now 1000 gram can be written as kilogram. So it will become 0.9 into 40,000. 0.9 into 40,000 is 36,000. 36,000 kilograms, because 1000 gram becomes 1 kg. So mass of this oil is indirectly given 36,000 kgs. So if I put the values now, the mass of the oil is 36,000 kgs into acceleration due to gravity is 9.8, but to make calculations easy, I will consider it as 10, into the height above which the oil is raised is 10 meters, divided by the time that is required is half an hour, that is 30 minutes. In seconds, I can write it as 30 into 60. And solving this, 0 will cancel straight away. 6 are, so it is 6,000, and 3 2,000. So the answer is 2,000. The power required is 2,000 watt, which can be written as 2 kilowatt. So the answer for question number 6 is 2 kilowatt. The power required, power of pump should be 2 kilowatt. So the next question is 7th question. 10 identical masses, mass m each, are connected one below the other with 10 strings. The topmost string, holding the topmost string, the system is accelerated upwards with g/2 acceleration. What is the tension in the 6th string from the top? So there are 10 masses. So the first mass, second, third, fourth, fifth, 6th, 7th, 8th, 9th, and this is the 10th one. So there are 10 masses. Each mass is of mass, each block is of mass m, and those blocks are connected with 10 strings. First string is right over here. Second, third string, fourth, fifth, 6th string, 7th, 8th, 9th, and 10th string. 10 strings and 10 blocks. In the 6th string from the top, considering the first string as this one, first, second, third, fourth, fifth, and 6th. Question is, what is the tension in this string if the system is accelerated upward with g/2 acceleration? Now to solve this, to find the tension at this particular place, I will draw free body diagram of this system, cutting the string over here. So if I cut the string over here, all 5 blocks, 1, 2, 3, 4, and 5 can be treated as 5m. And those 5 blocks are being accelerated upward with g/2 acceleration. So what is the upward force that is pulling it? That is the tension, right? When I cut it, I can show the tension over here. And the force that is in downward direction is their self weight, which is 5 mg. And from this figure now, the net force should be in upward direction as the system is moving up. So on this 5m mass, how much force is acting in upward direction? Net force, it is T minus 5mg. And this net force is equal to mass times acceleration, that is 5mg by 2, that is equal to 2.5 mg. And therefore the tension in the sixth string will be, if I take it to the right side, 7.5 mg. This is the tension in the string number 6. Similarly, you can find tension in any string. If you want to find tension in any general string, cut it from that point. Total downward force will be 3 mg, upward force is T. T minus 3 mg will provide net acceleration in upward direction. So for this particular question, in the sixth string, the tension will be 7.5 mg. Question number 8. Two galaxies of mass 9 billion solar mass and 4 billion solar mass are 5 light years apart. If the sun has to cross the line joining them without being attracted by either of them, which point should it pass through? Now see, galaxies are basically bunch of stars. Large number of stars are present in galaxy. So let us say this is one galaxy. This galaxy ka mass is about 9 billion solar mass. 9 billion solar mass. Okay, 9 billion solar mass. No need to convert it into kgs. It is not required for this question. And 4 billion solar mass is the smaller one. Okay, smaller galaxy. It should be in this way. 1 second. This is the second galaxy. Its mass is 4 billion solar mass. 4 billion solar mass. And these two galaxies are separated by a very large distance, which is 5 light years. 5 light years is a very large distance. It is basically, light year is a distance traveled by light in 1 year. So in 5 years, light will travel a very large distance, and that is 5 light years. Okay. Now, the sun, which will be very, very small as compared to these large galaxies, if it has to cross the line, then which point it should pass through so that it won't get attracted by either of them? Now, if it passes very close to this will attract it. Or if it passes very close to this galaxy, that galaxy will attract it. So we have to find that point where the sun, if it passes, will experience no force. Means let us say that is that point, that is the point P. If the sun has to pass through this point P and cross this line, it will feel no force because both the force of attractions will cancel out. Let us say this distance P is, distance of point P is x from the smaller galaxy. So from the larger one, the distance will be 5 minus x light years, right? So when the sun is present at this particular location, at this point, the attraction because of the smaller galaxy and the attraction because of the larger galaxy, both will cancel out. Therefore, it will experience no force. So basically, what should be the value of x? At what position it should pass? So net force will be 0. So simply we have to equate forces. Newton's law. What is force because of the smaller galaxy? It will be G, mass of sun, ms, mass of the galaxy, which is 4 billion solar mass, divided by distance x light year square. It is in light years, right? And what is the force because of the larger galaxy? It is G, mass of sun, which is ms, into 9 billion solar mass is the mass of this galaxy. 9 billion solar mass divided by the distance is 5 minus x light year, the whole square. See, no need to convert the units because the units are cancelling. Everything is same on both the sides. Light years will cancel straight away over here. And G will cancel, solar mass will cancel. So what is left is 9 upon 5 minus x the whole square is 4 upon x square. No need to cross multiply. You can take the square roots straight away. If you take square roots, you will get 3 by 5 minus x is equal to 4. Sorry, root of 4 is 2 upon x. Actually, there will be a plus minus over here. I will only take the positive sign because the other answer, if you take plus minus, you will get one other value of x. Okay, which will be on the other side of this galaxy where the values of gravitational forces will be equal. But right now we are only concerned about this point. So we will only go with single value of x. So I'll take only the positive one, and if I cross multiply it, it becomes 3x equals to 10 minus 2x. So 5x equals to 10, x equal to 2. So the answer is the point through which the sun should pass is 2 light years from the smaller galaxy, or 3 light years from the larger one. So the answer for question number 8 is 3 light years from the larger galaxy, 2 light years from the smaller one. Question number 9. While decreasing linearly from 5 Newton to 3 Newton, a force displaces an object from 3 meter to 5 meter. Calculate the work done by this force during this displacement. So clearly the question is from variable, work done by variable force, and work done by variable force means when force is applied on the object, if object moves from initial position to final position, and in this process if the force is changing, you cannot use force into displacement as the formula for work. In this case, what you have to do is you have to calculate work by integrating force with displacement from initial position to final position, from xi to xf. You have to integrate it. Okay, so integration is one way of solving the question, or the other way is also calculating the area under the force displacement graph. So if the force displacement graph is a curve, then integrating it from initial position to final position is nothing but finding the area under the curve. Remember, integration is nothing but finding the area under the curve. So calculation of work can either be done by integration, or it can be done by geometry by calculating the area under the curve. Which method to prefer? It depends on the question. If equation of the curve, equation of the force is given, you can integrate it straight away. But if equation of the curve is not given, whereas the diagram or some quantities are given through which you can plot the graph, in that case I can use the graph to calculate the work. So in this particular question, in question number 9, it is given that the force linearly decreases from 5 Newton to 3 Newton when displacing the object from 3 meter to 5 meter. So let us plot the graph. This is force versus displacement the graph. Force versus displacement. When x is 3 meter to x is 5 meter, the force decreases linearly. मतलब जब 3 meter पे object था उसका force, the force acting on it was 5 Newton, and then it decreases linearly. It becomes 3 Newton when displacement is 5 meter. So in this case, how much work is done? Basically, work done will be the area under the curve. If you calculate area under this curve, below this line, what is the area? This vertical part will be the area. And the area under the curve will give you nothing but work. How to calculate the shaded area? It is basically sum of a rectangle and a triangle, or else I can treat it as a trapezium because these two sides are parallel, and area of trapezium is equal to half into sum of parallel sides into height. So half is half. What is the sum of parallel side? This is one parallel, this is the second parallel side. The first side is 5, length is 5, and the other one is 3. 5 plus 3 is 8 into what is the height? Height means the distance between the parallel sides is 2. 5 minus 3 is 2. So 2 will cancel, answer is 8, and the area is nothing but work. So work done in this process is 8 joule. So the answer is 8 joule for question number 9. Question number 10, it is similar to question number 9. It is the question based on work done by variable force. In the previous question, the equation was not given. In this case, equation is given. So straight away calculating work is easy. It is integration f dx from x initial to x final. Okay. So integration, what is force? 6x square minus 4x minus 8 dx. And what are the limits? It is displaced from x equal to 1 to x equal to 2. So let us integrate this now. The integration of this term, 6x square will be 6x cubed by 3 minus 4x square by 2 minus 8x, and then limits are 1 to 2. First, instead of putting the limits, I'll simplify this. This is 2za, this is 2za. So the expression will simplify and become 2x cubed minus 2x square minus 8x, and the limits are 1 to 2. Now if I put the upper limit in the whole equation, it will become 2 into 2 cube is 8, 8 to the 16, minus if I put 2 over here, this will become 8, and if I put 2 over here, this will become 16. This is the solution. If I put the upper limit minus, now put the lower limit everywhere. So if I put lower limit, 2 into 1 cube is 2, minus 2 into 1 square is 2, minus 2 into 1 is 8. So solving this, 16 will cancel, it is minus 8, minus 2 will cancel, this is minus 8. So effectively the answer becomes 0. So the work done in this process is 0. No work is done. Question number 11. A ball of mass 100 gram is dropped on ground from 5 meter height, bounces repeatedly. During every bounce it loses 64% of its energy. 64% of potential is converted into kinetic. Actually, if the collision is perfectly elastic, all 100% converts into kinetic. Okay, so what happens exactly is, when you release the ball, its potential converts to kinetic, and after bouncing, that kinetic again converts to potential and it comes back to the original state. In this case, 64% energy is only converted, that is 36% energy is lost. Calculate these particular things. So to solve this question, first question is to calculate coefficient of restitution. See, to understand this question, let us see some basic example. Let us say a ball is released from height h1, and if after bouncing it only comes up to height h2. In this case, the collision is not perfectly elastic. If the collision was perfectly elastic, the ball would bounce back to the same height. In this case, there are some losses, so there is some coefficient of restitution which is less than 1. The collision is inelastic. So what is the definition of coefficient of restitution? It is defined as the velocity of separation of two objects after collision they separate. So unka relative velocity of separation to relative velocity of approach. Means before collision, when they come close to each other, the relative velocity at that time, and this is the relative velocity of separation. In this case, the two objects are, the first object is ball and the second object is the ground. And ground before and after collision practically remains at rest. So u2, that is ground ka speed before collision, this is u2, right? So ground ka speed before collision is 0, and ground ka speed after collision will be v2 is also 0. So only we are left with v1 and u1, that is the speed of object before collision is u1 and v1 is the speed of the object after collision. This is coefficient of restitution for a bouncing ball. Now don't worry about this minus sign, because v1 is upward velocity, so it is a positive number. This is negative. u1 being a downward velocity is a negative number, so negative will cancel and you will get a positive number. So we are interested in the speeds. What will be the speed of the ball just before collision? Means what will be its speed when it is just about to hit the ground, and what will be its speed when it is just going up after the collision. So you can use energy conservation principle. Over here the ball has got potential energy, right? So the potential energy is mgh1, and that energy converts into kinetic, which is half m. Its speed before collision is u1 square, right? So if you solve this, you will get initial speed of the ball u1, that is 2gh1 ka square root. This is the speed of the ball before collision. Now after collision, what happens? There are some losses, energy losses over here. So pura mgh1 will not convert into a whole kinetic energy after collision. There will be some losses. Therefore it won't rise to same height. It will only go up to height h2. So इस second process में after bouncing, उसका जो final potential energy है, that is mgh2 will be half m यहाँ का kinetic energy v1 square, that is velocity after collision. And solving this, m will cancel. v1, that is velocity after collision, can be calculated as 2gh2. So velocity before collision, velocity after collision. If I put over here, I'll get coefficient of restitution of the ball as 0 minus v1. 0 minus, what is v1? Under root 2gh1 divided by u1, since it is a downward vector, I will treat it as negative under root 2g h2 minus 1. Sorry, here it should be h2 over here, because v1 is the velocity of the first object after collision, and this is velocity of the first object before collision. So in denominator there will be h1 minus, this is 0, right? So solving this, 0 0 will straight away go, minus minus signs will cancel, and E ka value you will get under root h2 by h1. So directly remember the shortcut. If the question is of bouncing ball, and if a ball is released from height h1 and after collision it bounces back to height h2, the coefficient of restitution in this process is root of final height upon initial height. Right? So in this questions, the first one was calculate coefficient of restitution. So what will be the answer? Under root. Before the collision, the height was, it was released from 5 meter, and after collision it loses 64% of its energy. If it loses 64% of energy, it will lose height by 64%, because energy is only mgh potential. That whole potential energy mgh is lost, 64% रह जाएगा, only 64% is converted. So mgh will become 0.64 mgh. So this height will become 0.64 times, that is 0.64 of original height 5 meter. So the answer of this is 0.8. The coefficient of restitution in this question is 0.8. Okay, so now we have calculated coefficient of restitution for this question as it is 0.8, and now we know that coefficient of restitution can be calculated as under root h2 by h1. So in this particular question, a ball, it bounces from the height of 5 meter, okay, and after bouncing it goes only 64% up, 64% energy is used, sorry 64% energy is converted. So यहाँ का पूरा energy will be converted into kinetic, and after bouncing only 64% will be converted, so that its potential energy will only become 64%. So height will also become 64%, and what will be the height? इसका 64% is 0.64 into 5, that is 3.2 meter. So first bounce के बाद, this is the first bounce. After first bounce, the height it will gain is 3.2 meter. What will happen after the second bounce? After the second bounce, it won't come to same height of 3.2. It will bounce to a smaller height, and this height, this is second bounce. Second bounce के बाद, the height will be 0.64 into 3.2. And if you solve it, 64, 32, 8, 12, 19, 8, 4, 0, 2, 2048, that is 2.048 meters. 2.048 meters it will bounce up to after bouncing the second time, and after bouncing the third time it will rise to a height which will be again 64% of this, that is 0.64 of 2.048. If I treat this 2.048 as roughly as 2, so it will become 2 into 0.64 is 1.28, but because of this extra part I will treat it as 1.29 meters roughly, right? So this is the third bounce. So third bounce के बाद का height, right? So first bounce के बाद का height 3.2 meters, after second bounce 2.048, and after third bounce 1.29. Now questions are basically focused after third bounce, on the third bounce. So the question is, what is the speed after third bounce? If after the third bounce, while going up, what is the speed? So if it is going up to 1.29 meters, its kinetic energy should be equal to potential in that case. यहाँ से जब ऊपर जाएगा वो, तो उसका kinetic energy will convert into potential, right? So after third bounce, its kinetic energy should be equal to mg. H कितना है? H 1.29. Mass will cancel. G is 10. 10 into this is 12.9. V square by 2 will go up. So this is 12.9 into 2 is 25. 25.8 v square, and if you take the square root, 25.8 ka square root, we know that 25 ka root is 5, slightly greater than 5, roughly 5.1 something meters per second. My answer will be for the question number second. First question का answer we have already calculated 0.8, दूसरे का answer है 5.1. The third part of this question is impulse during the third bounce. What is the meaning of impulse? Yes, impulse is force into time, but impulse is also called as change in momentum, right? Impulse is also defined as change in momentum. So third bounce के पहले, just before the third bounce, when the ball was going down, what was the momentum initially? We need to calculate that. So third bounce के पहले, which energy was present with the ball? It had potential energy. कितना था वो? mgh. What was the height? 2. Let us treat it as 2. mgh. And that was converted into kinetic energy, half m v square. So what was the speed before collision? You can calculate the speed before collision. V square कितना आएगा? V square will be 4g. G is 10. So 40. V will be root 40. And root 40, 6.4, 6.5, it will be close to. But 6.5 will be larger. 6.3 तक जाएगा. 6.3 meters per second. So ये before third bounce का speed downward है, and ये after third bounce का speed upward है. So what is the impulse during the third bounce? And third bounce का impulse calculate कैसे करेंगे? So we need to calculate the change in momentum. So tell me, third bounce के पहले what was the momentum initial? It was mass times velocity. But mass is 100 gram. 100 gram is 0.1 kg. So mass into velocity if I do, this is velocity, this is mass. If I multiply कितना आएगा वो? This is 100 gram मतलब 0.1 kg. इसको 0.1 से multiply करेंगे, so it will become 0.63. But downward है इसलिए negative I will take. Minus. Okay, so this is initial. And what is the final momentum after collision? After collision the ball is moving up with this speed. So उसका final momentum कितना आएगा after collision? Mass into velocity. So उसका mass into velocity करेंगे तो it will be 0.51, but this will be upward, so positive. And change कितना आएगा? This minus this. So change in momentum will be 0.51 final minus initial. What is initial? It is already negative. So basically these two numbers will get added, and momentum, impulse, which is change in momentum, will be equal to this plus this. And 51 plus 63 is 114. That is 1.14 kg meters per second. This is the unit of impulse. This is the impulse. Okay, so till now we have solved first, second and third part. Coefficient of restitution was 0.8. It is unitless quantity. Speed that we have calculated, the B part, speed after the third bounce was 5.1 meters per second. And impulse after third bounce, impulse is change in momentum, is 1.4 roughly, कुछ तो आएगा 1.14 I guess, right? It was 1.14 kg meters per second. All these answers are calculated approximately, so slightly it will deviate from the textbook answers, but we have not used any calculators or any log tables. So all the answers are calculated approximately. So the next question is average force. What is the average force acting if the impact lasts for 250 milliseconds? Now force is defined as rate of change of linear momentum. Impulse तो already calculate किया है. Impulse is nothing but change in momentum. And change in momentum upon time अगर किया, time is given for this particular question, you can calculate force. So what will be the average force? Yes, it will be impulse 1.14 upon time, which is 250 milliseconds. लेकिन millisecond मतलब 10 raised to minus 3 milli. So if you solve this, 10 raised to minus 3 इसको दिया, तो 1, 2 and 3, it will become 1.14 upon 0.25 millisecond here. And 0.25 is nothing but 1 by 4. So that 4 will go up, and if you multiply it with 4, it becomes 4.56 Newton. This will be the value of force acting on that surface. during the third bounce. And the last question is find the average pressure, and pressure is defined as force acting per unit area. So these questions are in sequence. First calculate impulse, divide by time milega force, divide by area, you will get pressure. So pressure will be force by area. Force we have calculated 4.56 Newton upon area कितना है 0.5 but centimeters square. सेंटीमीटर का मीटर में कन्वर्जन 10⁻⁻² है but उसका स्क्वायर so 10⁻⁴ मीटर स्क्वायर. If you solve it properly 0.5 can be written as half. हाफ ऊपर जाएगा, इसका डबल कितना आएगा 9.12, इसका डबल 2 9.12 into 10⁻⁴ Newton per meter square will be the pressure acting on that surface. So these are the answers. Coefficient of restitution, speed of the ball after third bounce, impulse, average force is impulse upon time, time was given, and average pressure, that is force by area, area is also given. So these are the answers for question number 11.